Hello everyone, and thank you for joining today's prosthetic product showcase webinar. It's a couple of minutes before 3 o'clock here in the UK, so we'll be starting on time just as our last few attendees join us. So just bear with us, we'll be starting shortly. Thanks. Hello everyone, and thanks again for joining today's prosthetic product showcase webinar from Blatchford's. And we'll be showcasing our newly launched ElanIC microprocessor foot. Before we begin, I want to just run through some housekeeping issues. I want to make you aware that all participants are on mute for a better experience. And also this webinar is being recorded and will be made available at a later date on the Blatchford website. This will allow you to revisit and allow your friends who can't be with us today to revisit this recording and share the information. On the right-hand side of your screen, we've got a questions panel. We've got Mr. John Ross waiting to respond to any questions you may have as we run through today's presentation. We also have a handout available for you in the handout panel, so please feel free to download that. And at the end of this webinar, you're going to receive a questionnaire. Completion of the questionnaire will alert us to your continual professional development needs. And if you do complete that questionnaire, we'll make sure that we send you out an attendance certificate for your CPD file. Stay in touch with future webinars.
Bruce, can you just make sure that the slides are running properly? Because some people can't see the slides.
Okay. Can you see this slide? Can you see that, John?
No, I can't see anymore. Can everyone else see the slides? There's a couple of people saying they can't see the slides. Nope, there's a few people can't see the slides. Bruce, can you click on the box to
let's
show your screen again?
Okay,
thank you, Bruce. I can see the screen now. I think everyone else can. Looks of it. Yep. Thanks, Bruce.
Have we got some positive feedback? Okay.
Yep, on you go. Thanks, mate.
Right. Okay. So, as I was saying, if you can keep in touch with us at blatchford.com/webinars for our future webinar program, and I'll share my web address at the end of this presentation so you can keep in touch with any questions. So, my name is Bruce Rattray. I'm a prosthetist and I'm also a commercial manager with Blatchford's. And joining us today will be Patrick Handscombe, who is an ElanIC wearer, and let's not forget, also a KX06 wearer. So very experienced user in microprocessor hydraulic ankle technology. Patrick, are you there? And can you please introduce yourself?
Yes, I'm here. Hello, everybody. My name is Patrick Handscombe. Do you want me to say who I am?
Yes, introduce yourself and give us your background, please, Patrick.
Yeah, after working in the city in the 70s, I became a professional oil rig diver in the North Sea and elsewhere in the world, Far East and the Middle East. And then in 1993, I lost my left leg above the knee in a road accident. And since then, Blatchford's have used me to do various trials, particularly John Ross. And the most exciting of them all over the last few years, since the beginning that it started, is the Elan foot, which I might get a chance to tell you all about. Okay.
Lovely. Thank you, Patrick. So this is the agenda today. We're going to introduce the ElanIC and have a look into the technology behind this product, scientific evidence that backs up our selection and use of the ElanIC. We'll give you a detailed overview of the product and some technical information before moving on to our fitting recommendations and programming. We'll finish up with some common questions and summary, and we'll get Patrick's feedback along the way so he can give us the insight of the user. So let's have a first look at the ElanIC. So microprocessor control has been well-established part of prosthetic knee control since the early 90s, but similar microprocessor technology has only translated across into the ankle foot market in the last decade or so. And ElanIC is a combination of hydraulic ankle technology and microprocessor control to benefit the amputee by mimicking or replicating natural muscle resistance and ankle motion in real time. So the ElanIC is gathering all this information and making decisions about the way the foot responds to benefit the user's gait and standing support. ElanIC is a new addition to the Blatchford product range and offers a number of functional improvements over the original Elan version. And you can see the image up on the top right-hand corner of the Elan on the right-hand side next to the ElanIC on the left-hand side. So they've retained the slim, sleek contours of the original product, but incorporated a number of additional features. And because we've got this microprocessor control over proven hydraulic ankle technology, we get a lot of positive feedback from our users, commenting that this is a newfound freedom, almost like getting your original ankle back. So Elan was the world's first microprocessor controlled hydraulic ankle, and it remains today the world's lightest and most compact microprocessor hydraulic ankle available on the market. It really is a small, compact, sleek unit with a lot of technology and benefit for the user. The ElanIC is this new addition that gives this functional improvement, and you've probably noticed by now two of the main upgrades. First one is the introduction of induction charging, hence the IC in ElanIC. This gives a very simple wire-free way to charge the prosthetic device. You simply use the charging pad, which magnetically attaches onto the ElanIC in the correct orientation, allows the unit to be charged up. So this is a real advantage to anybody with manual dexterity or visual impairment issues, and allows for simpler connection with the reduced risk of any damage to plugs or cables. It simply clips onto the device. And you'll have seen from the introduction video, we've also now rated this product to IP67, giving it water protection. For the end user, this will mean greater freedom, less worrying about how they lead their life, whether or not water is going to have an impact on the reliability of their product. So it can be as simple as watering the plants in the garden, or having a water fight with the children, to paddling in a stream or entering the shower wearing your prosthetic device. And for those of you not familiar with the ingress protection code, IP67 gives full dust protection for this device. In other words, it's fully sealed, and a 7 water rating, which means that this product has met a minimum standard of 30 minutes submersion in up to 1 meter of fresh water. So let's move on to look at the technology in this device. So we utilize a hydraulic chamber situated on top of our energy storing return carbon fiber springs. And this allows us to mimic natural muscle function. We can replicate either concentric muscle reaction or eccentric muscle response. So eccentric response is where the muscle is lengthening, absorbing energy. A typical example of this would be anterior tibialis muscle controlling and absorbing energy around the ankle joint as the user walks downhill. That's your eccentric response, and we can mimic that energy absorption by replicating a very low resistance on the hydraulic chamber. So all that energy, all that momentum from walking downhill can be absorbed in the cylinder. If we want to create a concentric muscle response, more energy stored in the carbon springs and more energy returned to the user, similar to a concentric muscle contraction, we can instantly change the hydraulic resistance to high and transfer more energy to the springs. And in this way, the ElanIC can replicate muscle function and adapt in real time to the situation that the user finds themselves in. So here's a close-up of the ElanIC, and it's built upon our tried and trusted carbon fiber E-series blades. So we have a independently mounted heel spring and toe spring. So these don't cross-talk, they're not going to be fastened together, and they don't give you a dead spot at the point of attachment. They work independently of one another at the correct point in the gait cycle. The toe spring has a very long anterior to posterior split, which allows for independent deflection of each blade, and this creates the tripod contact point. So we have effectively a camera tripod giving you good stability at point of contact. The 3 rockers at the foot, the heel rocker, ankle rocker, and toe rocker, are all replicated by heel spring, the ankle pivot point, and the toe spring. And mounted proximally, we have this hydraulic chamber under microprocessor control, and the anatomical pivot point is located slightly anterior of the anatomical ankle joint, and this allows for easier movement on the hydraulic ankle unit. As you'd imagine from a powered unit, we've got the fully rechargeable batteries inside, battery charging pad on the back, and a battery indicator so the user can get a status update on the charge of the unit. We have a full sensory array, so this is gathering information through accelerometers, which tell when the foot is moving through space and its position in space, and also tilt sensors, which are measuring the angle of the ankle. And once you know the angle of the ankle, you can also calculate the change in angle and understand the velocity that the patient is walking at. So this combination, this sensory array and this real-time processing of data means that our users don't have to adapt the way they walk. The foot will change for the user depending on the situation they find themselves in. And there's 5 key modes that the ElanIC can offer. Normal walking. This is very similar to the calibration mode during the programming phase, where standard preset resistances on the ankle apply. Then we have a braking mode, which initiates when the patient's walking down a ramp and provides a stabilizing, slowing, controlled descent. We have the assist mode that provides additional energy return to the user as they walk uphill. Standing mode will sense when the user is standing still and provide additional ankle support for balanced loading and long-term joint health. And we also have a fast walking mode, a cadence response. This is where the foot is assisting the user to walk at a higher walking speed for a longer period of time. And ultimately, this will give them more energy and they'll feel better at the end of the day. The 3 modes, brake mode, assist mode, and fast walking mode, are all patented and unique to Blatchford's. So what actually happens? What does the user actually feel as they're walking down a slope? Well, simultaneously, the ElanIC will detect the introduction of the slope and simultaneously decrease the plantar flexion resistance, which means that the foot reaches foot flat far quicker. Having the foot stable on the ground means that the user is ultimately more stable and more controlled. You will also see that the dorsiflexion resistance ramps up simultaneously. This is providing the braking effect, resisting the forward rotation of the pylon and socket and providing this braking action. It's effectively absorbing the momentum of the user and slowing them down as they walk downhill. And this will provide a much more controlled style of gait. It will eliminate excessive knee motion and generally provide a far safer descent down slopes. If we look at the slope ascent process, the system works in reverse. Now, the plantar flexion resistance becomes very high, so the foot from the second step is being held in a dorsiflex position at heel strike, and this effectively places a greater compression or more weight through the heel spring. Greater energy is stored and ultimately released, providing forward assistance. Because we also have decreased dorsiflexion resistance, the user can move their center of mass over the foot faster. They can maintain their walking speed despite walking uphill. And again, it will allow them to move into swing phase earlier as well as loading the toe spring earlier in the gait cycle. So this two simultaneously changes allows for increased efficiency walking uphill. Now, while we've covered these 2 points, I think it might be a good idea to bring Patrick in. And Patrick, if you can share how you feel both walking up slope and descending down a slope, please.
The first thing I think is remarkable is that you don't feel in any of the modes that you're walking over the toe. It's a very easy motion, that it's very natural. I live on just off a high street, which is a hill. Walking up and down the high street, I can walk up and down really without another thought, just go up and down, and one doesn't feel one's walking uphill over the toe, and also going downhill. It doesn't run away with you. You feel very secure that you're able to make sensible progress without running away. And yet, of course, I've got a KX06, so it requires the toe action to unlock the knee. And again, no problems whatsoever. It's perfectly natural. You don't feel that you have to make any extra effort to unlock the knee or to resist it unlocking it when you're walking downhill. Okay.
Great, thank you, Patrick. And that's a very good point that you've highlighted there about the knee stability for our transfemoral users. So the next mode to talk about is the standing support mode on the ElanIC. So if our wearer stands still for a short period of time, we see an increase in both the plantar flexion and the dorsiflexion resistance. So this added stability at ankle level allows for better loading and greater stability. So previously, amputees were maybe more inclined to place weight on the sound side. This added stability in the standing phase allows them to stand a more equalized weight on both sides, and it's particularly of benefit to bilateral amputees who already have to work a little bit harder to stabilize their body weight on their prosthesis. So when standing still, we've got this added support. And I should also add, it's not a complete ankle lock. There's still a very small residual motion there, but it's much, much higher than the standard setting. We also have a fast walk mode on the ElanIC, and this makes the foot a truly speed or cadence responsive foot. The ElanIC will understand when the user is walking faster, and it will change its response to help allow the user to reach their fastest walking speed and maintain it. And I would strongly recommend that if you get the chance with any Elan wearers, just find an open space, get them to achieve that fastest walking speed and maintain it for as long as possible. And I've never encountered a foot that allows this to happen as well as the Elan and the ElanIC. What happens, so the foot will detect this change in speed, the plantar flexion resistance will increase. This will again allow for more energy storage in the heel spring and ultimately more energy return, more forward propulsion to the user. And we'll see that simultaneous reduction in the dorsiflexion resistance. So the hydraulic ankle can rotate forward far easier. Tibial progression is facilitated, and it allows the user to bring their center of mass over the foot and keep moving forward. So, Patrick, can you share any thoughts on fast walking and standing support?
Yes, as many will know, the KX06 is easier to walk on when it's the least stable. And that means that with some ankles it can be a problem. But with the Elan, you even when the knee is set to flex very easily, the stability of the foot means it doesn't keep unlocking the knee on you when you're standing still. So it's very stable. One of the other things is that you're able to use different shoes and boots on the ankle, so that when you're walking and you change speed, you tend not to catch your toe at all. That's the other benefit of it, because the way the foot works. So you can change speed and so on very easily, perfectly naturally, without really noticing it at all. Okay.
Thank you. And that's another very good point, Patrick. The Elan and the ElanIC are not specifically designed as patient adjustable heel devices, but they will accommodate changes in heel height within the prescribed range allowed by the cylinder. So you can make these changes in footwear, and the device will self-align and allow you to walk better as opposed to a fixed ankle device. And one common feature across all of the Blatchford hydraulic ankle feet is that as we enter into the swing phase, the foot maintains its dorsiflexed position. So as the toe leaves the ground, the hydraulic ankle is already in 3 degrees of dorsiflexion, which is maintained throughout the swing phase. And this increases toe clearance during swing by up to 20 millimeters in conjunction with the more natural release at the hip and knee segments. So this reduces reduces the risk of tripping, of catching the toe, and ultimately leads to an increased safety for our wearers. So let's move on to the scientific evidence that surrounds Elan. And this is a summary page of 3 studies ranging from 2016 to 2018, looking at microprocessor foot walking down a slope. And when we get onto the programming section of ElanIC later, you'll see that you can switch off slope descent or switch off slope ascent assist features. And this is what the researchers utilized in these studies. They essentially converted the Elan from an active microprocessor foot to a passive hydraulic foot, and compared the benefits of the 2 systems on a patient group. So for the microprocessor control on the Elan, what we see is foot flat occurs up to 8% faster than the passive hydraulic systems. So this is an increase in safety to the patient because the foot's reaching the floor and achieving foot flat sooner. We also see a reduction of up to 15% on the compensatory residual knee motion. So this is what you would typically see on a patient walking down slope with a fixed ankle prosthesis. You see the tendency for the knee to shoot forward, some knee instability, and the user has to use active muscle control to resist that. We've also measured this reduction in sound side involvement, so up to 8% reduction there, and an increase on the prosthetic side of 26%. So this microprocessor action improves symmetry between sound and prosthetic side. There's also a reduction in the angular velocity of the shank. So this is the forward rotation angular velocity of the pylon and the socket. And this is what we'd expect to see. A reduction of up to 9% means that the Elan and the ElanIC is doing exactly what it should do. Providing this braking effect is absorbing this energy, this increase in prosthetic negative work. So it's absorbing energy and preventing the build-up of momentum as the user walks down a slope. So all independently gathered information, and I'll be providing the links for this later in the presentation. Looking at slope ascent, the assist feature could be deactivated as well, and the microprocessor foot could be restored to a passive hydraulic system. And there's less published evidence on the slope ascent, but what we can comment on is that there's this clear increase in the symmetry between sound and prosthetic side when the patient's walking uphill, in addition to the increased energy efficiency. So we know that there's a benefit from using hydraulic ankles, and these studies are proving that there's an additional incremental benefit to the user when moving from a passive hydraulic system up onto a microprocessor controlled hydraulic system. And one of the more recent research articles is looking at standing support mode. Now, the hydraulic ankle technology will align itself regardless of whether the wearer is on a flat surface or pointing down the slope or facing up the slope. It will self-align and then apply this increased ankle stability. If the system's in true alignment with the ground reaction force passing through the ankle and the knee joint center, we'll see an absence of moments. But if there's a misalignment between the ground reaction vector, that's when we start to see moments being introduced to the system. So a moment is a force acting at a fixed distance away from the center of rotation. And generally for prosthetic users, these are bad because if you have a moment acting on your prosthesis while you're standing still, this will be destabilizing the knee, and the user will either have to introduce knee flexion to accommodate that, or they'll have to use active muscle control to fight that force to maintain the system in a stable place. So if we look at the moments for the microprocessor Elan and ElanIC compared to Echelon, we see a 41% reduction, indicating higher standing stability. And if we compare to a fixed energy storing and return foot, it's up to 59% less. So an even higher incremental saving. That's on the sound side. If we look at the prosthetic side, we see up to a 43% reduction on the joint moment on the prosthetic limb compared to energy storage return feet. But the headline figure that caught my attention was for bilateral amputees. I mentioned earlier that the Elan and the ElanIC is a great foot to benefit their overall stability, both in standing and in forward progression. And what this study highlighted was that the moments around the knee for wearers of Elan and ElanIC were in the natural range. So these were equivalent to an able-bodied person when standing. And that was a fantastic finding. So the last three slides have been focusing on the incremental benefits, the additional benefits from microprocessor control over hydraulic passive systems. But we do know already that hydraulic systems give a lot of benefits to users. If we look at both the socket loading rates, how fast forces are transmitted onto the residual limb, we see an 87% reduction, and that's highly important for long-term tissue health, because we know that skin and tissue tolerate that slow loading response better than fast, sharp loading forces. And because we have a hydraulic ankle that's actively moving, we have this anterior pivot point facilitating movement of that ankle joint. We see a reduction in the internal load stress up to 81%. Also, we know about the reduction in metabolic cost, up to 12% on hydraulic ankles compared to fixed ankle energy storing feet. Increase in walking speed of up to 7%. So the self-selected walking speeds of this patient group is faster. They can get to their destination sooner than with other designs. And we see a better loading characteristics between sound side and prosthetic side. Reduction in the plantar pressure on the sound side of up to 26%, and a 24% reduction in the center of pressure movement. So users feel more balanced and stable using hydraulic ankle technology. Let's look at some detailed product information now on the ElanIC. If we look at our user selection, we can say it's open really to a broad spectrum of patients, transtibial, transfemoral, bilaterals, specifically designed for K3 amputees, but we can also demonstrate a benefit for the K2 amputee in the higher echelon of that grouping, and also for the K4 patient who is a low to moderate impact level. And we could say that users who are changing terrain, changing cadence, changing their walking speed on a regular basis would benefit. Any user who's looking for a smoother, more efficient gait would benefit. Anybody who regularly finds themselves walking on or across slopes would benefit from the added stability, both whilst moving and standing. And anybody looking for a reduction in energy expenditure and an increase in socket comfort. Top weight level for this ElanIC is 125 kilograms. The exception to that would be on the K4 category of user, where the maximum body weight is 100 kilograms. So as you can see, we've added inductive charging. This is a well-established and safe method of charging electronic components. It relies on a primary coil within the charging pad. When that's placed in close proximity to the secondary coil, the alternating current in the first coil generates an alternating current in the second coil, and this can be rectified and used to charge the onboard battery pack. Very simple to charge. You simply place the charging pad in close proximity to the ElanIC and it will snap into place. There's no worry about making your plug-in charger align correctly. There's no worry with damaging the pins. Very simple and easy to use system. Typically, a charge will take around 5.5 hours. That is slightly longer than the traditional wired connection, but still well short of your average resting period overnight. And the charge will give you typically 24 to 48 hours, depending on the activity of the user and the age of the battery cell. But we're absolutely expecting a minimum of 24 hours full and active use on one complete charge. And this slide also highlights that if the battery is reaching a very low charge, the foot itself, the ElanIC, will sacrifice the standing mode. So the first thing the user will be aware of if they stand still is that the high resistance we would normally expect for standing mode to be no longer present, but they do retain fast walking cadence response. They retain their ramp assist and their braking mode coming down the slope. Here we have a quick and easy comparison chart that looks at Elan and ElanIC head to head. So with the addition of the onboard Bluetooth and the revised charging method and some of the additional requirements to allow for that IP67 water rating, there has been a small increase in the overall weight of the unit. Just over 80 grams of additional weight, but that has been minimized as much as possible. We've now got the IP67 rating as classified, so that's up to 1 meter submersion for a 30-minute period, and a slight increase in the charge time. I should also draw your attention to there's a very small increase in the overall build height. So from sizes 22 to 26, we're seeing an additional 2 millimeters of build height, and the same on 27 to 30. So when the product's supplied to you, we've got the ElanIC fully assembled with glide sock and foot shell. We've got the clinician's manual user guide, so your patient can familiarize themselves with the product. The battery charger unit with an assortment of different plugs to allow movement between different charging zones. There is an external USB Bluetooth adapter should you require to plug one into your PC or tablet. But as I mentioned before, Bluetooth is now on board on the ElanIC. And you also have a USB key with the programming software. Let's look at alignment, and it follows the existing system that we've utilized before on our hydraulic ankle systems. So you will know from your assessment of the patient and from your marks taken during casting the necessary flexion that needs to be accommodated at the interface between socket and pylon. So accommodate that flexion. Place the user's shoe onto the prosthesis and then place it onto the Blatchford alignment wedge. This takes the guesswork out of alignment because it will find the neutral point on the ankle range for you. So place your prosthesis with the shoe on the wedge, and at that point fully plantar flex the foot. So take hold of the socket or the pylon, pull it backwards until the foot is fully plantar flexed. And at that point, you can drop your build line down from your socket and make sure that it passes through the target line identified on the side of the ElanIC unit. Once you've done that, you're ready to move on to static alignment with the patient. Now, we do have a new way of programming ElanIC, which allows users of Android devices, either phones or tablets, to program ElanIC, in addition to the previous method, which was laptop or PC based. So you've got your USB stick, and if you're working with an Android device, you should take the Android app file from the USB stick and transfer that across to your Android device. Simplest way to do that is connect your Android device to your PC through a cable and transfer it that way, but you can, of course, alternatively email this file directly to the Android device. Once it's on the device, you can navigate to the app file, tap on the Elan icon, and you'll be asked do you want to install this application? At which point you would give the positive command and tap install. Installation will begin, and the final stage of that will be accepting the licensing agreement. That completes the load onto the Android device, and you can either exit or tap open to continue programming. Now, ElanIC has Bluetooth on board. This is a change from the previous Elan. So because it's now situated on board, we have to have a method for enabling Bluetooth, making the device visible to the programming device. And this video is going to run us through how to carry that out. First step is to fully dorsiflex the ankle and lift the foot beyond 45 degrees. Now we have a display from the LED that tells us the battery charge. But if we wait a further 5 seconds, we enable the Bluetooth. Stage 1, we get a solid blue light. And then if you then drop the foot, the blue light starts blinking, and that indicates that the device is discoverable. Now, in case you're wondering why has the Bluetooth blue light stopped flashing, that's because the video is stopped. In real life, it would continue flashing until you make your connection. These are the programming screens for Android tablet and Android phone. The default credentials are automatically populated and you can log in. With the Bluetooth enabled on the ElanIC, you will be able to scan for available devices to connect to, and your device will indicate all available Elans that are enabled and within range. And it's worth noting that the ElanIC app will only discover available Elan devices. It's not going to identify any other Bluetooth devices. So once you recognize the ElanIC that you want to work with, tap on it, and you can then receive the following pairing request if you've never connected with the device before. This happens only on new devices, and once you click OK, you can then notice that the flashing blue light on the side of the ElanIC changes to a solid blue light, meaning you have the ability to send and receive information. Stage 1 is of the programming screen, and this is taken from an Android phone, is to confirm that the alignment vector is correct and vertical. So with the patient standing with feet level in a normal resting position, we want to see that green line at 90 degrees following the dotted line. With the correct bench alignment, you should be quite close. You can, at this stage, make some minor adjustments to the plantar flexion, dorsiflexion if you need to, but you should be quite close at this stage. New users may benefit from having the ability to view your screen as they become accustomed to moving backwards and forwards in this new freedom at ankle level. The next stage is to adjust the basic resistance settings of plantar flexion and dorsiflexion, and we always recommend to do these in isolation. Start with plantar flexion and get the user to walk on the device and concentrate on heel strike. So we're looking for feedback like the heel feels too hard, or they get a jarring feeling at heel strike, which would indicate that a reduction in the plantar flexion resistance is required. If your user is telling you that the heel feels soft, or they feel like they're sinking at heel strike, or the foot is slapping down on the floor too fast, let's increase the plantar flexion resistance. Play around with the settings till you've reached a comfortable value, and then move on to dorsiflexion. And again, the user can provide feedback at the end of the gait cycle. So does the toe feel too hard? Does it feel like they have to climb over the toe, which would indicate a reduction in dorsiflexion resistance? If they give you the feedback that they're falling off the toe, increase the dorsiflexion resistance until you find the right balance to give a smooth progression throughout stance. Next stage is calibration. Please select whether you're working with a transfemoral or a transtibial patient using the tick boxes. And you can now press the start button, which will initiate the calibration process. You'll receive a countdown of the number of steps required and ask your user to walk across a flat level surface until the countdown reaches 0. You will then receive a message from the app telling you that calibration has been completed successfully. You also have the possibility to turn on or off 5 main modes of ElanIC: fast walk, ramp assist, ramp brake, standing support, and the battery indicator. In my experience, I've never switched these off. I've kept them all active, and it may only be required for some older users who prefer to have the user without the ElanIC without standing support. But my starting recommendation for new users is to have these all activated. The final screen, the status screen, will give you real-time feedback on the battery, charge status on your ElanIC, and also give you feedback that the tilt sensors are working, and as the user is walking on the device, moving on the device, you'll see this tilt sensor giving real feedback and moving its display. So here's an overview of the programming feature on ElanIC. Stage 1, enable the Bluetooth as we saw before. Dorsiflex the foot, lift beyond 45 degrees, hold for 4 seconds and you go through the battery charge indicator. Hold for a longer 5-second period and you get the solid blue LED. At this point you can drop the leg and the solid blue will change to a flashing blue, indicating the device is discoverable. Use your device to connect to ElanIC. Accept the programming device, log on, and scan for your Elan that you're working with. If you're happy, make the connection by tapping on the device, and then check your alignment vector at stage 1. And as you can see, you can either swipe through the screens or use the ribbon at the top to reach the desired screen. So, standing patient, verify the vector. Stage 2, adjust the plantar flexion and dorsiflexion resistances for smooth transition. Select the amputation level, start calibration, and now we see an active countdown of the steps until calibration is complete. Calibration is confirmed. Use the screen to switch ElanIC modes on or off. And as you can see, we've got live feedback on tilt sensor and battery mode. If at any stage you want to return the ElanIC back to its factory status, you can carry out a factory reset and you get confirmation that the device is no longer programmed and you can begin the process again. So that was programming the ElanIC using a phone. The tablet display is slightly different. This is what you can see on screen at the moment. And all screens that we saw on the phone are now available on one tablet screen. And we would recommend you work from top to bottom in the same order as we did on the Android phone device. Verify the vector, adjust the plantar flexion and dorsiflexion resistances, and complete the calibration. So slightly different layout on the screen of the tablet. For PC users, you still have the option to program through PC, and this group should be aware that if you're using the existing Elan software, it will also work with ElanIC. You don't need to upgrade the software that you already have on your PC. New users can get that software from the USB stick included with the device. And PC users, again, follow the same stages: alignment vector, hydraulic settings at the ankle, confirm the amputation level, and click calibrate. One thing to be aware of is that PC users used to connect to the external dongle on the ElanIC. Now they will have to add each individual ElanIC onto their paired devices before programming. So ElanIC is a great step forward in allowing the user to be able to get through their life and not worry about the impact of water. And it's achieved partially through having this sealed unit that allows no moisture ingress, but of course through the presence of induction or inductive charging. When you use inductive charging on the ElanIC, you should be aware that the charging pad should be in direct contact with the posterior aspect of the ElanIC. So please move any socks or tights or any fabric out of the way to allow direct contact with the device. And here we have a video showing that process. So when we have power to the charge block, it's illuminated blue, and it simply magnetically attaches onto the back of the ElanIC. And during the charging process, we're going to see that LED on the ElanIC flash and display the charge status. So this is slightly different from other types of chargers. What we will see is upon connection, the charging pad LED will start to pulse and change slightly the color of the LED, but more importantly is the LED on the foot unit itself. This will flash indicating the charge status of the device. If the battery is fully charged and you make the connection with the charger, you will get a single initial flash from the body of the ElanIC. After that, no further flashes. So this will indicate to you that the unit is fully charged. And that single flash is to give you that information. As it's charging up, we're going to see one flash from the battery indicator for a low charge, 2 flashes for medium charge, and 3 flashes as we're almost full. When charging is complete, we'll have a solid blue light on the ElanIC, but after a period of time, that LED will extinguish itself. So if you wake up in the morning, go to the device, and there's no light on the ElanIC, don't be alarmed. Don't think that the charging process has failed. You can verify that by a short restart of the process to get that single flash. It's a built-in system that the light stops illuminating when fully charged. And the user, of course, can do a live assessment of the battery charge during their day. And we just have to get the foot beyond 45 degrees to achieve that. And it can be done in a number of different ways. So Richard kneeled down to get that signal. You can also elevate the foot for transfemoral wearers. And the battery feedback occurs twice, again, on a system of 1, 2, or 3 flashes. And one other way to achieve this would be to sit perhaps on the edge of a chair and just lift the prosthesis up so the toes resting on the floor to get that feedback. So I'll maybe bring in Patrick at this point, who's been working with the ElanIC inductive charging for a period of time, just to tell us, how'd you get on with it, Patrick?
Absolutely no problem at all. Just to go back a bit, the programming of the foot is an absolute breeze. As John probably will confirm, this is no problem whatsoever. It's very quick and very straightforward. And just every night, I wear my leg for about 16 hours a day, just take my leg off and clip the charger pad onto the back of the ankle, and there you go. Leave it, it's fine. Never had any problem whatsoever.
Lovely, thank you, Patrick.
Okay.
And that's exactly what we want to do. We want to eliminate all the stress and worry from the user, so they don't have to concern themselves with these things, both on the charging and the water resistance, both these fronts. A couple of hints and tips. If you've already enabled ElanIC, if you've enabled the Bluetooth by dorsiflexing the foot and lifting beyond 45 degrees, that enables the Bluetooth. But if you repeat that process again, dorsiflex and then lift the foot beyond 45 degrees, this is actually going to turn the Bluetooth off. It works in reverse. So just be aware of that. Also, if your ElanIC receive any command for 15 minutes, this Bluetooth will automatically turn off to save power, and then you'd have to re-enable it if you wanted to program. Under other circumstances, if you went out of range, for example, the ElanIC will revert back to discoverable mode for a further minute, during which time you can reconnect. So a couple of common questions that we've come across, and this also applies to our hydraulic range. Sometimes we get feedback that the ElanIC or the Elan doesn't have a large range of motion. It actually has 9 degrees of hydraulic motion made up of 6 plantar and 3 dorsi. But actually, in conjunction with the spring deflection, the movement on the carbon springs, it has over 30 degrees, approximately 33 degrees of motion in total, which corresponds to natural anatomical ankle motion. And more importantly, because the Elan and the ElanIC control the resistance through the range, this provides the best possible control for the patient. If you've got a huge range of motion with no control, the user is not going to benefit. Why would I choose the ElanIC when I get most of the same benefit from an echelon? Well, as we've seen earlier, ElanIC provides adaptive resistances. It's changing the hydraulic resistance in real time to give the user additional benefit on ramp descent, ramp ascent, and also a true cadence response, a true response to walking speed changes. So please consider these incremental and proven scientific benefits that we detailed earlier to justify the additional benefits that a user will get from ElanIC over a passive hydraulic system. For your programmers, PC users, do I need to pair with every new ElanIC? Yes, you do, because you need to make your device aware of this new Bluetooth device, add it to your accepted devices, and once you've done that once, you won't need to pair again. Another question, I've already got ELAN software on my PC and don't want to use an Android device. Do I need to update the software on my PC? The answer to that is no. Previous versions of our ELAN software will also program ElanIC. So that's giving you some flexibility, especially if you're a PC user. And for the app users who are using older versions of the ELAN, like the one shown in this image here, you can also program those ELAN older versions, E3 as shown, using your app. So just to summarize and finish off for today, the ElanIC is a great new addition to the Blatchford product range, and it will be available parallel to our current ELAN. So ELAN and the new ElanIC are both available in our product range. Both these products gives you microprocessor control over a hydraulic ankle, providing real-time resistance, giving you speed and terrain benefits, improving symmetry and balance for the user. It also provides standing support and ramps up resistance for users, giving superb energy and stability benefits, especially for bilateral users. ELAN and ElanIC are the most compact and lightweight microprocessor feet on the market, slim, sleek, streamlined. And now with the induction of charging, our users don't have any plugs or direct contacts to worry about. Simply place the charger on the back of the ankle for stress-free charging. And the real breakthrough, IP67 water protection. So this gives the user less stress, less worry about exposing their device to water. They can go through puddles, go through streams in line with our recommendations in our user guide, and as submerge the item up to 1 meter. Gives you great flexibility. So thank you very much for your attention today. I hope you've enjoyed this introduction to the ElanIC. Please visit our website for more information and to get the latest clinical compendiums with the latest scientific information on our hydraulic ankle range and our microprocessor controlled hydraulic range. I've been your presenter for today, bruce.rattray@blatchford.co.uk. Please send me through any questions you may have. And a very big thank you to Patrick for his contribution today. Thank you, Patrick. After this webinar ends, you'll get our questionnaire. Please fill that in with any feedback for future suggestions or advice on our webinar program. This will also alert us to your requirement for an attendance certificate. And check out our webinar program at blatchford.co.uk/webinars. Thanks again for all your attention, and I look forward to your presence at our next webinar. Thank you.